Next, we looked at probability and then calculating multiple probabilities, where probabilities are mutually exclusive or not mutually exclusive. So we'll look at that in number 10. And then 11, where we looked at independent and dependent probabilities, the and probabilities where we have to multiply. Both of these will use your calculator. So if you want to pause the video to get your calculator, you can do that. But you will need that. And as I'm doing the calculator sequence, if you feel like it's going too fast, remember you can always pause and rewind. So number 10, in a survey taken of 300 people entering a restaurant, 60 people plan to get kids' meals, 85 plan to eat an appetizer, 50 plan to eat a dessert, and then 45 plan to get both an appetizer and dessert. So since some people are fitting both categories, appetizer and dessert, that makes those people not mutually exclusive. So that's where we have to account for that and then possibly subtract some of those outcomes that are part of both appetizers and desserts. So if a customer of a restaurant is chosen at random, what is the probability the member will get a kid's meal or get an appetizer? So we're going to find the probability of a kid's meal, call it K, or appetizer, we'll call that A. When we're dealing with an or, that means we're going to add our probabilities. So we find the probability of somebody choosing a kid's meal, that's going to be 60 over 300. Plus, we're going to add the appetizers. Number of people who plan to get an appetizer is 85 out of 300 people. Figure out what's the chances of somebody getting one or the other. We're going to add those together, 145 over 300. We could leave it as 145 over 300, or we could simplify that down. I'm just going to leave it as that. We'll head to our calculator. And you can take 145 and divide by 300. 145 divided by 300, give us our percent, 48.3%. And we'll go back and look. It doesn't say what we need to round to, so we'll just say this is 48.3%. So about half the people would get a kid's meal or an appetizer. Part B, get an appetizer or get a dessert. So still the same idea. We're going to be adding our probabilities. So we check how many people are getting appetizers. So we just did that. That's 85 out of 300. Plus how many people are getting dessert. That's another 50 out of 300. Now, the people that are getting desserts and appetizers is not mutually exclusive. That means some people are choosing to get both outcomes, which is fine, but we do have to account for that, because if you're counting 85 people getting an appetizer, 50 people getting a dessert, some people are getting both, you're going to be counting those people 2 times. So we have to subtract out the people who are getting both, 45 minus 300. And 50 and 45 make 5, and then add that on, that's going to be 90. So we got 90 over 300.
Bring your phone outside and take videos on it.
Yeah, I'll be on just a little bit. 90 over 300 is going to reduce down to 3 over 10, which is going to equal 30%. So about 30% of the people would be getting either the appetizer or the dessert. And we did subtract off the 45 people because we already counted them when we did the appetizer stats. So we have to make sure we subtract those off. All right, we'll scroll down to number 11. In a bag of bubble gum, 6 pieces are pink, 14 are blue. Keep track of that. That's your sample space. You got 14 pieces of gum in your pack. What is the probability that a blue bubblegum piece is drawn from the bag 3 times in a row if the bubblegum is not replaced every single time? So you're going to probably eat it. So what's the chances of getting blue? Our first time we reach into that bag, you have an 8 out of 14 chance, because there's 8 pieces of blue, 14 total. using probability, that's going to be our chances the first time. And we're doing probability of getting 3 blue. And 8 out of 14 is my first chance. Now, once you've eaten that blue piece of bubble gum, you're down to 7 pieces of blue, and you've eaten one out of the total, so there's 13 left. This is a dependent probability because now your probabilities change to get to the next one. And then the next time you eat it, you're down to a 6 out of 12 chance. So those are our 3 probabilities, and we are going to multiply those together. So we'll head to our calculator, we'll hit alpha y equals to open up a fraction, that very first one, 8 out of 14 first time, times, next time alpha y equals, we have a 7 out of 13 chance, and then we'll hit alpha y equals, and last our chance would be a 6 out of 12. So we multiply those 3 fractions together, we get a 2/13. We'll change that to a decimal. 2 divided by 13, about a 15.4% chance. If I went through that too fast, you can pause it, rewind it, check it out, walking through those steps. But either way, you're going to get about a 15.4% chance, which is a little bit higher than I thought it would be, but since over half are blue, chances of getting blue is more likely, so 15.4% would be our result. So there's your whole review. So if you take some time to watch these, thank you, and good luck on your test, and hopefully see you soon. See you later.